All right, ladies and gentlemen, let's quiet down, please. Okay, I'm going to ask you, please save your notes for this section. Okay, you will use this a lot. We are going to talk about what we call derivative rules, and this is part 1 of 2. Okay, I will show you 2 sets of rules that I hope you will find very, very useful. But before I do that, remember what we did last day? The definition of derivative? Yes, limit of h. Okay, approach to 0. Yeah, keep going. F of x plus h. Yes, minus function of x. Yeah, all over h. Right. So really, it's the slope, and then we put the limit in front to make it the slope of a tangent line, which is aka known as the derivative. So what I'm going to ask us to do today is let's see if we can actually use this definition a few more times, okay, and help us figure out the derivative of a constant and also the derivative of a power, okay? So a constant, of course, is just a number, right? A number. And a lot of times we'll just use the letter C to represent the constant, okay? So what I'm asking you here is if the function, okay, so if f of x, the function, is equal to some constant c, I want you to find now f prime of x, the derivative, okay? And remember the derivative is this lovely function up here, and I guess I should have wrote down f prime of x in front, okay? That limit of h approach to 0 of f of x plus h minus f of x all over h. So, shall we use the definition for this function here? Let's try. So what's f prime of x? I will use the definition. It's the limit of h approach to 0. Now, what is this f of x plus h stuff then? And what is f of x in this example here? C plus x? C plus h? Let's think about this, okay? You don't need to write this stuff on the side if you don't want to. If I said f of x equals to c, what's f of x plus h? Remember the idea of function notation is wherever you see x, replace it with what's inside the bracket? Oh, sorry. Okay. So what's, hey, where's the x? Here. Where's the x? C plus h? There's no x, right? So there's no x. There's no replacement. So what is it? Just c. It's just the constant. Okay. There's no x, right? Yeah, but there's no x in our function over here. Remember the idea of function notation, and let's just quickly review. For function notation, let's say I had f of x equals to 3x plus 2. That means wherever you see x, you replace it with what's inside. So if it was x f of 5, this will become 3 times 5 plus 2, right? If I gave you something like this, f of star, that would be 3 times star plus 2, right? But my function now is this, f of x equals to c. So now if I said, what's f of star? Well, there's no star there, or there's no x, right? So it's still c. If I said, what's f of happy face? It's still, no, it's not happy face, it's c, right? Make sense? Constant, right? Constant means it's always the same. No matter what value of x, the y value is the same. It's constant. Okay? So this whole thing here is just equal to c. Good. So let's write this down. Limit h approach to c is c. And then Vincent's saying, hey, f of x is also c. You're right. So it's c minus c all over h. What's c minus c? What's c minus c? 0, right. 0 divided by h. Now what do we get here? You get, what? 0 over 0? Okay, now, technically yes, but technically no. Okay, so let me just explain this to you. Okay, so write that down first, 0 over 0, and then I'll explain this to you. Okay? You know how before I said when you do limits, when you have 0 over 0, that's that weird case? and then you have to find some sort of factor, and then usually you cancel something out, and then it evaluates, right? That's true when I have the limit of h approach to 0, and I have an h in the top and an h in the bottom, where I actually plug in 0. But for this one here that we're doing, this 0 in the numerator, okay, is created by taking c minus c. I didn't actually plug in any number. Okay? Remember, the idea of h approaching to 0 means it doesn't really naturally equal to 0, but it's getting closer and closer to 0. So what I'm doing here is I'm taking the real 0, okay, divided by a number that's really, 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 really close to 0. What's 0 divided by a number? 0. So technically, this is not 0 over 0. This is actually just 0. Okay? So what I want you to understand here is that the derivative, which is the slope of the tangent line, of a constant is 0. And that's what I'm going to ask you to write down here. So if f of x equals to c, then f prime of x equals to 0, and box this. This is the derivative of a constant. Okay? Now, over here, I want us to show, or I want to show you this visually, because I want you to see what this looks like. Okay? How do I draw a... Bless you. Woo. How do I draw a function where it's a constant? How does it look like as a graph, as a picture? The constant function. How does it look like? Horizontal line. Exactly. Okay, so here's my constant function. Let's call this point here C. Here's my constant function. It's a horizontal line. Good. Looking at this picture, can you tell me what the slope of a horizontal line is? 0. There you go. You just proved visually that the derivative of a constant is 0. Done. Okay. So once again, I'll say the slope of this line must be 0. So therefore, that just proves that this is correct. Okay. Now, some of you might be thinking, Mr. Lee, what's this weird stuff here? D over dx in the C. Okay. Remember how I told you earlier that calculus was invented by two people pretty much at the same time, but in different places? Right? So they all had their own types of notation. So this is Newton's notation, the one on the left. And this is that Leibniz guy from Germany and his notation. And d dx just represents the word derivative. Okay? So he's saying the derivative of c, the derivative of a constant is, well, it's still going to be 0. Okay, so d dx just means derivative. You'll see that notation. And part of the issues with calculus that people have is that there's so many different ways to write this thing called the derivative that people get mixed up. Okay? But they all mean the same thing. So if you see this d dx or you see f prime x, it means derivative. Okay? All right. Let's move on to the power rule. So I'm going to ask you to use the definition of the derivative again to evaluate these three things. And then we're going to take a look at the results. And I want to see if you can compare the results with the original function to find a pattern. Okay? So let's split this up. How about people with birthdays between January and April? Who are you? All right. Congratulations. You get the easiest one. January to April. Okay? Those of you from June, oh wait a minute, May to, let's say, October. Who's May to October? October's included, yeah. Oh, a lot of you. Okay. You do the next one. And then November, December, who are you? All right. You are with me. November to December, we do the last one. Okay? Now, I like you all to quickly use the limit definition. So I'm asking you to use this, the limit of h approach to 0, f of x plus h minus f of x all over h to calculate these. Okay? Yes? My birthday is actually, no, it's not November, December.
This month?
Mine's in August, actually. Sometime in August.
We will keep talking until you talk.
Help you out, okay? Remember square root stuff? Not so nice, right? So I will start this one with you and then get you started, okay? By the way, for the rest of you, start doing A and B. Remember f of x plus h minus f of x all over h. The key part, nope, no simpler notation. But remember it's the square root, so x plus h minus root x, okay, all over h. By the way, for us dear friends in November to December birthdays, when you have square roots and you're evaluating this limit, what must you do? Anyone remember? Conjugate. Correct it. Yeah. Don't forget to conjugate both the top and the bottom. And by the way, for those of you already done parts A and B, go ahead and do part C as well. We're all going to have to do it anyways. Okay. So go ahead, please, and continue on. I think I gave you enough hints for part C.
I have a video of him singing. Yeah. And I have a video of him playing guitar.
Why does everyone have it?
I'll put it on YouTube. Video. And jumping over each other. That's not solution. Well, the one where they jump over.
Keep Kiana as a little cat. You'll be better. What?
Okay, ladies and gentlemen, I've got a few of your classmates putting the answers on the board. They have correct answers. So I'd like you to copy down what they've done if you haven't done it yourself. And then for those of you who are already done, I'm going to ask you to see if you can figure out this lovely pattern. Okay?
Sorry?
I can't see you writing.
Alright, never mind.
I got you guys.
Then come up to the board if you can't see the writing.
Mouse. A mice. Really? Really?
It's like a bullet. It's like a bullet. 100%. Best presentation ever. Yeah. Oh, wow. Yeah.
Make mistake. No limits, okay? Just that part. Once you evaluate plugging in, it's gone. Okay, ladies and gentlemen, so go ahead and copy these down.
Oh, it is small. It is really small. Sorry.
It's so pretty.
Okay. Copy them down, and once again, I'd like you to see if you can find the pattern. And Bronte, don't give it away. But it's neat.
I can't see the ceiling. I don't feel like writing the solution.
So I forgot to record all this. All of you online, here are the answers. Go figure it out. Okay? Yes, Anna. Yes. But be careful here. I'm not saying I want to take the derivative of a constant. I'm taking a derivative of a constant multiplied by a function. I'm not asking you to find the derivative of a constant first. This rule, the constant multiple rule, says that if I have a function that's a constant multiplied by some other function, you just ignore the constant, find the derivative of the function, and then multiply back in with the constant. No, it's different. Yeah. Okay. Okay, ladies and gentlemen, let's do part B here. Okay. This looks messy, so can you please write this as a constant multiplied by a power of x? Now, what's 1 over root x as a power of x? What's root x as a power? Half. Yeah, and because it's in the denominator, it must be negative half. Good. Now go ahead and find the derivative. So once again, ignore the constant. So just write that as 1/3. And now find the derivative of x to the power of 1/2. What's that? Negative half. X to the power of? No, not 1/2. Subtract. Negative 1/2 minus 1. 3 over 2. Yes, negative 3 over 2. Good. Okay, remember, you're reducing the exponent by 1. So negative half minus 1 is negative 3/2. And then this becomes 1/6 x to the negative 3 over 2. Done. Okay? I'll help you with C, and then we'll take a look at D, E, and F. Ooh, scary. Okay, so once again, I always ask you to please rewrite this as a constant multiplied by a power of x. What is 1 over x squared as a power of x? X to the power of what? Negative 2. Thanks, Vincent. Okay, good. So now, knowing that, you should be able to easily now calculate the derivative. We'll once again ignore the negative 10. What do we do with x to the power of negative 2? We'll bring down the 2. Once again, reduce the exponent by 1. So what's this going to be? Negative 3. Excellent. And then let's simplify. Yep, 20x to the power of negative 3. Or if you want positive exponents, 20 over x cubed. Okay. Now, for D, you just do the same thing to every single piece. That's it. Same thing with E. F is a little bit more tricky, but I'll let you do D and E first. Okay? You try D and E. Let's see what you get as your answers. Okay, I'll give you 2 minutes to try D and E. No answers? Okay, one answer. Let's do one answer at least. One's better than none. Okay, for D, how about the first term? What's the derivative of x to the power of 4? 4x cubed. Good. What's the derivative of 3x cubed? 9x squared. Awesome. How about 5x squared? Minus 10x. And what's the derivative of 2?
18x.
Shh. Okay. There's 2 ways you can do this one. Is 2 a power or a constant?
Constant.
What's the derivative of constant? 0.
Really?
Now, if you didn't see that and you thought, well, let's use the power rule, well, remember, 2 as a constant just means it's multiplied by x to the power of 0. Okay, so if you were to do it like this, you'd bring down the exponent, 0, reduce the exponent by 1. What's 2 times 0? Still 0, right? So, remember, the derivative of a constant is 0. There's your answer. Okay, let's do E then. What's E? Negative 10x to the power of 6. The derivative is negative 60x to the power of 5. How about 3x squared? What's that derivative? 6x. What's the derivative of pi? 0. Good. Pi is a constant. You hate pi. Okay. Okay, and then how about 1 over x? Now, remember, 1 over x as an exponent is x to the negative 1. So now if you know that, can you figure out the derivative? It becomes negative 1 times x to the power of negative 2. Good. And this last one here, I'll say that's 2x to the negative 2. So what's the derivative here? That's minus, and I guess I'll have negative 4x to the power of negative 3. So trying to simplify this one for E, I'll say that's 60x to the power of 5, which is negative, plus 6x minus 1 over x squared, if I want to have positive exponents, and plus 4 over x cubed. That's your derivative for e. Okay? Let's do f together, okay? Bless you. Okay. Hang on. Okay. Okay, now, ladies and gentlemen, let's do f together. You're like, a fraction. Oh, maybe you should take the derivative of the top pieces and then the derivative of the bottom piece. Don't do that. Okay? For fractions like this, I want you to try to simplify. Okay? Simplify and rewrite as powers. Okay? That's what you should do for now. Until next day when I show you how to do stuff with division. Okay? Now, what do I mean by simplifying? I'd like you to break this up into actual individual terms. So let's divide every single term in the numerator by 2x. Okay? And then I'd like you to simplify and rewrite them as powers. That's how you should do f. So what can we do? Let me continue to rewrite this as, how about 1/2 x? What's 2x divided by 2x? Oh no, that's not x, that's 1, right? And then 5 over 2, and I'll have an x in the denominator, so I'll just write that as x to the power of -1. Sound good? Okay, once you've done that, once you've written them as powers, okay, now is the time to take the derivative. So now, find the derivative. What's your question? Ask. Oh, no? Okay.
I think we have the same question.
What's the question then? Why is it?
Well, I figured it out, so.
Oh, okay. Okay. What's the derivative of 1/2 x? Okay, I will do 1/2, ignore it. What's the power for x? It's x to the power of 1, right? So when I bring this down, it becomes 1 times x to the power of 0. Well, what's x to the power of 0? 1. So that whole thing here is just 1. So 1 times 1/2 is just half. Good. Okay. What's the derivative of 1?
0.
Good, 0. And then what's the derivative of this ugly thing, 5 over 2 x to the -1? Once again, I will rewrite this as 5 over 2 times, bring the exponent down, -1, x to the -2. And if you were to simplify, I'd write this as -5 over 2 x squared. Ta-da. Okay. Now, to clear up some confusion that some of you might have, I know Anna was saying, Mr. Lee, I don't really get what this is for. You're right, because I haven't actually showed you what this is for. I've been teaching you mechanics, kind of like how to add, subtract, multiply, and divide, right? I've shown you the mechanics of how to find the derivative. Now, in examples 3, 4, 5, and 6, let's see if we can apply this idea of the derivative, okay? So now what I'm going to say is using the results from part D from above, because part D is the exact same question as what I have in example number 3, okay? If I asked you now to find the equation of the tangent to the curve at the point x equals to 1, what quick thing can we do? Plug in x. So yeah, so first of all, I need to find the slope, and the slope is really equal to the derivative, and the derivative is equal to this function, y prime equals to 4x cubed plus 9x squared minus 10x, and this is from above. And what do I plug in for x, Edison? 1. Right on. So now if I plug in 1, I will now calculate very quickly the slope of the tangent at 1. 4 plus 9 is 13, minus 10 is 3. So look at that. In 2 steps, you've actually found the derivative and the slope. And in the last week, it took you like 8 or 9 steps. Isn't life good? Yes, Anna?
So does this mean that when you're looking for the slope of this tangent line, you always use the derivative?
is always what, sorry? Yep. The slope of the tangent line is always just the derivative. Yep. So now, once you know that, can you figure out, please, the equations? I asked you for the equation, right? So what's the equation of the tangent line? And remember, this is a specific equation of the tangent line at this point, x equal to 1. Remember, at different values of x, you'll have different tangent lines because they look different. Our lovely grade 10 format of y equals mx plus b. See, isn't this great? We're putting everything together that you've learned from like elementary, grade 8, grade 10, grade 11, grade 12. You should be like, wow, this is so beautiful. This is like, it's all the different pieces of the artwork coming together.
Yeah. But you do it.
Okay. M is 3. X is 1. What's y? Negative what? How do you get negative 3 for y?
Oh, you saw 3.
No, I said, what's y? And then Helena says negative 3. Yeah, note, okay, to find y, what you want to do is plug in x equal to 1 into which equation? Well, it's the original equation, right? The first one. Not the derivative one, but the first one, okay? And then I think if you do that, Helena says you get negative 3. I trust her. Maybe that's a mistake, but we'll see. So I think b is equal to negative 6. And so all that work, your equation of the tangent line, y equals to 3x minus 6. Can someone confirm that this is correct? So I can have faith in Helena? Yeah? No? Yeah? It's correct? Okay. All right. 3 more quick examples and we'll be done for today, okay? Wait. Okay, I'll wait. For those of you who don't want to wait, turn the page. What does the word normal mean, by the way? In math.
I was thinking physics.
What does it mean in physics?
Like, you know, the perpendicular line to the interface.
Oh, perpendicular line to interface? Cool! It's the same thing in calculus. Okay. This is perpendicular. Okay. So, turn to page 3. It says, using the results from part D from example number 2, now find the equation of the normal line, meaning find the equation of the perpendicular line. Now, let's go back to good old times in grade 10. How do we find the slope of a perpendicular line? Negative reciprocal, right. Slopes of perpendicular lines. See, all that grade 10 stuff coming back. Are negative reciprocal. Oh yeah. Check your notes if you still have them. So the slope from before was 3. So therefore now what's the slope of the perpendicular? You threw all your notes away. Tis, tis, tis. I'll sell you mine.
Oh no.
Funny.
Okay. So what we got? Slope of the perpendicular line is negative 1/3. So now go ahead and find the equation of the normal line. Oh, sorry, that's my symbol for perpendicular. Like a little T with a little right angle, and then an R for perpendicular. I'm sorry.
Wait, why is the R perpendicular?
Perpendicular.
Oh, because I saw torn.
Sorry.
I saw torn.
I don't know why I put an N. Sorry, I don't know why I put an R in the N.
Isn't it just like a...
Yeah, okay, fair enough. I think it was because I was saying to myself perpendicular, and then I put an R at the end. Because it ends with an R. I don't know. It's June, we're all tired. Okay. Y equals to, in this case, negative 1/3 x plus b. Once again, what's x and y to solve for b? What's x and y? From above. Oh, 1 and negative 3. Okay, so negative 3, 1 plus b. What's negative 3 plus 1/3? Negative 9 over 3 plus 1 over 3 is 8 over 3. Look at this. There's your equation of the normal line. Okay. All right. I've got 10 minutes left. Perfect time to do 2 more examples. Okay?
Wait, the last one was 5.
Yeah, that's right. All right. Okay, let's focus here for the last 10 minutes, please. All right? Richard, you ready? Okay. Okay. Here's a different type of question. Now I'm saying, can you tell me where the points? Can you tell me the points on this curve that have a horizontal tangent? So this curve is something like this. It's weird. And I'm saying that there are different points where your tangent is horizontal. Now, the question is, you need to find it for me. Well,
Just be like x equals like 1.
maybe 1, maybe 2, I'm not too sure. We'll see. We'll see. We'll see. What's constant, though, when I say a horizontal tangent? What's 0? Ah, good. Horizontal tangent means that the slope is equal to 0. Hey, what word do we use for slope in calculus? Derivative. So really what you're saying is this. You want to find x when the derivative equals to 0. Okay? Okay, quiet down, please. Okay? Let's do this together. Shh, gentlemen, please. Okay? So now how can you figure out the derivative for me together, please? Let's do the derivative. What's the derivative of 1/3 x cubed? Okay, I'll do the whole steps. 1/3 times 3x squared. Yeah. Okay. The other one, 3 over 2 times x squared. What's the derivative of x squared? What's the derivative of x squared? 2x to the power 1, thank you. Then we have minus 10. What's the derivative of x? That's just 1 times x to the power 0. And what's the derivative of 5? 0. Okay. So let's simplify this. Okay, this is the derivative. We'll simplify. 1/3 times 3 is just 1, so that's x squared. 3 over 2 times 2 is just 3, so 3x minus 10. And since this is the derivative, it's supposed to equal to 0. Wow. Doesn't that look familiar?
Oh my god.
Wow. Yes, my favorite F word. Factor. Find two numbers that multiply to negative 10 and add to negative 3. 5 and 2? Which one's positive? Which one's negative? Negative 5, positive 2. Sweet. So you do this, you get x minus 5 equals 0, x equals to 5. Over here you get x plus 2 equals 0, so x equals to negative 2. And we are almost done, except I asked you for the points, not just the x-coordinates. So you now have to figure out the y-coordinates. And to do this, I will allow you to use your graphing calculator, if you have yours with you. There you go. It's in your locker. Don't go get it. Just watch. Okay? Remember how you can do things really easily in your graphing calculator? I will just say this. I'll store x as 5. And then I just type in the actual function, so I don't have to do it like again. 1/3 x cubed. Calm down. It's just math. Uh-oh, nasty number, but that's okay. Negative 245 over 6. Aren't you glad you have a calculator to do that? Okay. And then for negative 2, I'll do the same thing. I'll store that as x. I will recall. How do I change to a fraction? Oh, I'll show you. Press math. Then choose number 1. Then press enter.
49
So your two coordinates then, okay, are 5, comma, negative 245 over 6. And then negative 2, comma, 49 over 3. Ta, ta da, ta da 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 da. Okay, one more application, and then by the way, next day when you come back, I'll show you some more derivative rules. Okay, we'll do one where we'll find out a rule for multiplication, and then also one for division. And I don't have a song, but I will introduce to you a jingle.
Jingle. Whoa.
Okay, number 6. Okay. Okay, this question is a little bit weird, so let me explain to you what's going on, okay? It's kind of weird because it's not really doable in life, but whatever, okay? Okay. Pretend this stick that I'm holding up here is like a path for a particle to go, okay? Think of a little particle here, okay? Shh. Hey, listen up. Particle, or little mousey, whatever, okay? Particle. It can either go right or it can either go left. That's all it can do, okay? Right or left. Can't go up, can't go down, can't do anything else. Just right or left. So what I'm saying here in the question is a particle moves according to this law of motion given by this function, okay? Where t is 0, so at time 0, that's where it starts. And then when t increases 1 second, 2 seconds, 3 seconds, this function here describes where it is along this curve, okay? So for example, if I asked you, where is this at 0, you would be plugging in f of 0. So where is this particle? It's at 10. So if I were to draw this out, and you don't have to, I guess what we're saying, here's my number line, here's 0. We're starting at 10. Okay, so this is where the particle starts. And then if I asked you, well, what happens at 1 second, you would then ask me, or I'd ask you to calculate this, what's f of 1, and you'd plug in 1 for t. So we get 1 cubed is 1, 1 minus 9 is negative 8, negative 8 plus 15 is 7, 7 plus 10 is 17. So after 1 second, you know that this thing traveled this way, and now at 17. So fast? Okay. All right. So my question to you is, this particle moves, okay? We know it starts this way, then it might stop, might go like this. Who knows what it does, okay? But it does something. Now, back to the calculus part, how do we actually find a formula to calculate velocity? So remember, this formula up here that I highlighted in yellow is like your distance or displacement? No, displacement, right, where you are. So this is your displacement, okay? How? Oh, right, your position. Sorry, position. Oh, sorry. I haven't taken physics in like 10 years. Actually, more than that. 17 years. Okay.
Oh my god.
Wait, so physics 11 would be your last year.
Sorry. 15 years then. 15 years.
So you took physics 12?
So what age are we now?
So we could ask you physics 12 questions?
Don't ask me physics 12 questions. I don't remember.
Wow.
Okay.
Wait, no, then we can calculate when he was born.
Okay. How do you find velocity when you're given position? Shh. How do you find velocity when given position? Divide by time. Remember, velocity is just position. Yeah, divide by time. But if I asked you for the instantaneous velocity, which is what I'm doing here, you would do what in terms of calculus? Derivative. Yes. So now I want you to say or note this. The velocity is really the derivative, okay, of position. Remember, derivative is slope, right? So slope is connecting a quantity divided by another quantity. I will stop this. You listen to that first. Let's find the derivative, please. So what's the derivative of t cubed minus 9t squared plus 15t plus 10? Huh? What's the derivative of t cubed? Let's do this first. T cubed is 3t squared. How about minus 9t squared? Negative 18t. How about 15t? 15. What's 10? 0. Good. So there you go. There's your velocity function. There's v of t. Done. So now, knowing this, can you answer part B for me? Part B just says, what is the velocity at 3 seconds? So meaning at the time of 3 seconds, how fast is it traveling? So we'll just plug in 3. Yep. 3 times 3 squared minus 18 times 3 plus 15. Whoa. 3 times 9, 27. 27 minus 54 plus 15. Negative 12. By the way, what's our units here? Negative 12 what? Oh, read the question. We are American today. Feet per second.
Oh my god.
Okay. Now,
Wait, we don't measure in feet?
no, we measure in meters.
But what about in height? When we measure
Meters.
our height, it's in feet.
No. If you look at when you do a driving test and all that kind of stuff, it'll always go by centimeters. Yeah.
Oh.
Okay, part C. When's the particle at rest? What does at rest mean?
Zero.
What's 0? Not t equals 0. That means when your initial starting, it's v equals 0, right? At rest means that your velocity equals to 0, right? Velocity equals to 0. So make velocity 0, and guess what? You have to now solve for t.
Wait, don't you just plug in t for 0?
No, t for 0 means your starting position, okay? When I say at rest, that means your velocity equals 0. Okay, factor out to 3. Okay, Richard. Let's go ahead and factor once again. I'm rushing this because I want to get you out of here. Okay. Now I want to do part D, and I'll let you do part E on your own, okay? Hey, you guys, stop talking, okay? Last one. At least part D. Find the formula for acceleration. How do you find acceleration then when you know velocity? Change in the velocity by change in time. Right. So acceleration is really your delta V over delta T, right? Well, in calculus, what do you think we're going to do now? It's the slope, yeah, or the derivative of the velocity function. Right. Right. By the way, before I do this, just to let you know, remember when you guys did those graphs in Physics 11, where you graphed like D versus T, and then you had to graph V versus T, and then afterwards you did A versus T? Remember how they gave you something like this, where it was like a parabola, and then the V versus T became a line, and then this became a horizontal line? Well, think about it. What function or what equation is a parabola? X squared. Oh. Hey, velocity is the derivative of x squared. What's the derivative of x squared? 2x. Oh, that's a line. Oh, by the way, an acceleration is a derivative of velocity. What's the derivative of 2x?
0.
No.
What?
The derivative of 2x is 2, a constant.
My mind does not. My mind.
Anyways, you finish off D and E. We'll take a look at it next time, okay?